Well, good evening, everyone. My name is Urmi Kavi, and I am a architect by profession. Have been in architecture for 10 years. Have done different types of architecture for different domains. Have worked as cloud infrastructure, um, end user client, and then smart grid, and have worked as solution architect, also as an enterprise architect as well. So that's a little bit about me. Let's get going. Well, first and foremost, welcome to the Student IT Architecture Competition 2020. This is a fun competition. I've been part of it since the last 5 years. I think this is our fifth year. Rakesh, correct me if I'm wrong, but that's my recollection.
Yes,
Um,
yeah, we are in fifth year.
and it's a winning or losing is not the agenda here. The goal is to share the architecture practices which you can take forward in your careers and back to the work and organizations, or any other areas of IT that you do plan to pursue your life, or even if you're in business side, just having some better understanding of how IT systems are pulled together will get you ahead. And we do the competition to share our practices, because when I was an architect, and I'm sure when Rakesh was an architect or going through school, the architecture was not something that we learned anything about in school, and there weren't enough architects around to ask questions or share information or share their experiences with. So it's been great to be a participant in this entire process, and to learn and to share. So because technology is constantly changing, so I want to thank each and every one of you. I know it's not easy. There's a lot of work that goes into the competition for the students, as well as the organizers and all the mentors and everyone who comes and shares their story and journey with this effort. So I am here today to talk about IT infrastructure. So what is IT infrastructure? I don't know how familiar everybody is with ITIL, but ITIL is a information technology infrastructure library. So it's a governance, best practices, methodology or process. I thought, which came from Britain of all the places, and it was written in the, I want to say, the 80s and 90s, because technology was picking up, and they said, well, there's this whole new capability coming along with IT. We need to put some governance and processes and policies and standards established so that we can manage and govern technology better. So ITIL, and you can get certified in it in case anyone's interested. There's different levels. You can be a master or a foundational level certification. I mentioned it because it's good to have. It's not a very difficult exam. You can, but it's not at the same time super easy either. It's medium, somewhere in between. If you if you take the time to learn it and go give the exam, it's not super challenging, is what I'm trying to get to. Um, it defines IT infrastructure as hardware, software, networking, and facilities. Hardware, I think everyone's familiar with, because if you have a smartphone or a laptop or a desktop, that's considered part of hardware. You have to plug it into a wireless device, into a wireless network somewhere. Well, that network is being served from a hot spot or a point, which is a network router or a switch, or some device is letting you connect to the internet. So that's another piece of hardware. Um, the software that is showing up on the web is stored on some piece of hardware, which is called the server. And then there's all this storage that goes with a lot of data that is served on the web pages. That's stored in databases, which are then stored again in a storage. And so when you think about infrastructure, think of all the things that are around you, even when you use something as simple as a smartphone or a laptop to get your homework done, or if you're at UW, um, if you've used the mail system. It used to be Dante. I think it's gone now. I'm not sure, but if I'm probably dating myself. But anyway, what I'm trying to get to is that every day, everything you do where you interact with your smart devices or even your wearable Apple Watch or a Fitbit, there is a lot of IT infrastructure that's gone into making that device function the way it is functioning for you. And then all this infrastructure is usually housed inside a facility. It's a building, it's called a data center. So ITIL methodology refers to infrastructure as the hardware, the software, the networking, and facilities components. So the key components of infrastructure are the data centers, the servers, or compute is another word you'll hear, storage, networking, your endpoint devices, and then security controls. And security is imperative. It's almost, it needs to be ingrained at every level of the in IT infrastructure, also at the software layer, at the data layers. When you move the data or when it's statically stored on a storage platform, security comes into play. When users log into the systems, security comes into play. If you've ever done if you log into your phone with the password, or if you've got a swipe if of your finger or whatever, using biometrics, or if you've set it up for multiple logins, all that is part of the security posture for that device. And I cannot emphasize how important security has become because of so many data breaches and violations and data leaks that have happened because of various reasons. These issues don't crop just from hackers. I want you to be aware that they can also be from just plain human error, or someone wasn't accessing systems which they're not supposed to, or they got additional privileges to certain areas of the system which they didn't need to. So think about all those things when you think of security. I just want you to know, keep that in mind. I think next week or so we'll probably have a webinar that's coming up, is what I've heard from Rakesh, just on security. So I will not be going into super depth, but I can't talk about infrastructure without talking a little bit of at least about security, because it's ingrained. It needs to be part of the solution and not an afterthought. So what are our options? So you've got all these components I just pointed out, which at a very high level make up this technology stack for infrastructure. So what are our options, or how can we consume these services or these capabilities? Well, we have three options, and I'm just going to stick to the high level three for now. There's a private cloud. What that means is I go get a data center facility, and I go buy my own servers and network and storage and power and heating and cooling and all those systems to make the environment in that data center amiable or ambient temperatures so that these devices will operate optimally. And so that's an option. That's how traditionally data centers used to serve up compute and storage and networking capabilities up until, I want to say, the mid 200s. So like 2000s, sorry. So in the past decade, what has happened is new technologies have evolved and emerged, associated with virtualization, which has made things much simpler and easier, highlighting the need for no longer needing your own data centers. So that's where the public cloud comes in. So if you've ever used Hotmail, now I know that's 20 years ago, some of you may not remember Hotmail, but if you have a Yahoo account or a Live account or a Gmail, you're consuming server storage, network connectivity, data center, that in which these servers are stored in, from Amazon or Microsoft or Google or whoever your email provider is, email service provider, whether it's an ISP or whoever. So that is called a public cloud. You don't own the server, you don't own the network, you don't own anything, but you pay for consuming the services for that email service. And then the third one, which is what a lot of corporations do, and that's the hybrid model, because a lot of companies already have their own data centers from the 90s and from 80s, 90s, and 2000s. People are going with the hybrid model because of the data security. You want to keep some of the most critical stuff on-prem because of some of the challenges that come with cloud. So on-premise is your own private cloud. And then there may be things that you want to put in the public cloud because of the opportunities that are offered in the public cloud. And I'll talk about them a little bit more. But at a very high level, best practice standard is private cloud refers to things on premise that you own, manage, govern, and are responsible for ensuring security on. And public cloud is where you have a third party, like such as Amazon, Microsoft, or Google, or there's some other cloud providers too that are specific, like Stream is another one, and that one is just specific for SAP systems. So there's a lot of other niche vendors. Oracle has their own private cloud. So the hybrid cloud model is you have some on-prem, you have some things in the cloud, and those systems talk to each other. So that's what the hybrid cloud is.
Urmi, I think we lost you for probably 20 seconds or so.
Oh, the last piece. Okay, I can
Yeah.
repeat.
Okay,
So,
thank you.
so the last, yeah. So the last, as I was closing out, I was referring to, so private cloud is managed by the company, by the owner. So you own everything. You get to own all components of it. The public cloud is, it's a shared responsibility where you consume the services from a third party like Azure, Microsoft, Stream, Oracle Financial, or sorry, Oracle or Google, and you consume some of the services, but then there's other pieces of the cloud that you own, like your applications may be owned by the individual who's consuming those services. And the hybrid cloud is, it's a hybrid model. So you have some systems that are on premise, some systems may be in the public cloud, and then they are connected to get the best solution or meet the business needs as necessary. So it just depends on which solution you will use, is dictated pretty much by your business requirements. So, Rakesh, were you able to hear me?
Yes.
Rakesh, okay,
Yeah.
cool.
Perfect.
All right, moving on. So, IT infrastructure, architecture, design considerations. So, as you are pulling the solution together for the case, or even if you're going to be working at a place as an architect, some of the things to think about as an infrastructure architect, or even if you're a solution architect, some of the things to think about for infrastructure design are scalability, business continuity, security controls, IT infrastructure management, the cost, and the support model. These are some of the key. There's a lot of other things to think about too. Um, And that's because there are dedicated infrastructure or cloud architects in companies, so who spend their time, most of their time, pulling solutions together for different types of systems based on these capabilities. But there's even other finer things where you talk about availability, and then you can get into more details about the different types of storage and various other things. So this, I'm just touching on the tip of the iceberg. There's a lot to learn here. And I'm sharing this from an architecture perspective, some of the very, very most important or critical things to think about when you're pulling the design together for infrastructure architecture. So scalability. So scalability refers to growing or increasing infrastructure components without complete replacement. And what does that really mean? And you can scale up or you can scale out. So here's simply putting it. So if you have somebody who has, I'm going to make it simple. So if there's a family of 50 people and they all live in the same building, in the same house, and then they realize that, oh, you know what, they got married and they have more kids, so now they're running out of space. So what they do is they start building up on the same in the same house. They're building more floors, but then there's a city permit limit, and they say you can't build more than 2 stories. So they say, okay, that's it, but we are, we're growing and we all want to stay together, but we need more space. So what do? They had more space next to them, so they start adding similar homes or identical homes next to that one home they had. So what I'm trying to define is, when you build up is when you build vertically, you're scaling up. So in servers, for example, you can, when you build your application, you can write it such, you're writing your application and you have to tune your infrastructure, in particular servers and storage, so that you get the maximum performance and you're optimizing your hardware resources. And to be able to do that, you want to write your code in multi-threading ways, or use different ways of so you're using the memory optimally. Now, most programmers don't have to think about those things, because if you're using .NET platform, it has garbage utility, which will clean up and release your variables from memory. So then the memory is cleaned for the next program to run and can use the compute capacity. So programmers no longer need to think a lot in those areas anymore. But you still have to think about it, that what is the most optimal way in which I can utilize my hardware, my server resources, so that I can get the most value out of the infrastructure investments. So for example, let's say it's a website that's getting built, and we start with the requirements of, monthly growth is 500 users for the next 2 years. Well, what ends up happening is that they're not just getting 200 users, they're getting 500 users or 700 users because the website became very popular. Well, you don't want the business to have to go replace those servers. So what you do is you add additional CPU capacity, or you add more memory, RAM, you add more storage, so that there's more capacity to grow the server, so that it can cater to that increasing workload. And sometimes, depending on how the application is written, you may need to scale out. So you may need to add multiple servers. If you think that 500 users are hitting the system and it's not performing optimally, and now all of a sudden, like, we have this scenario where the storm's happening, so now everybody wants to get on the website to see what the status of their outage is. So then there's maybe 10,000 people hitting the website at once. So we have to then figure out a way to scale and add more servers so that we can take in that extra load. So those are think of the use cases as you're building out your applications and how you want to propose your infrastructure to increase and grow to meet the changing needs and the use cases of the business. So that's what scalability means with regard to IT infrastructure. The next thing I want all of you to consider and keep in mind is business continuity and disaster recovery. I cannot emphasize that enough. Now, I want to be clear. Disasters can be natural or man-made. So natural, I think everyone knows, earthquakes, you've got floods, snowstorms, those are natural disasters. If you think about volcano eruption, if you think about man-made disasters, we've got the coronavirus happening in China. That is a disastrous situation because we've had companies close stores. There's been companies that have pulled their employees out. There's probably not enough labor to go around to continue business as normal. So that is a disaster. Another use case would be man-made disaster would be like there's a power outage because there's a big power problem and the data center is on the West Coast or someplace got impacted because of something, or there's a script written which was for maintenance and it didn't go well and it took down a bunch of servers because that's what the script was written to do for maybe one server, but it just replicated and did it for all because of an error. So those are human errors that can cause disasters. Businesses cannot be disrupted. We are looking for ways to keep the business running and continue to cater to our customers. If you are a Netflix or an Amazon Prime or any kind of streaming consumer, or if you've been on the web, I mean, when was the last time the World Wide Web went down? You may have had an outage because of a ISP issue, but the expectation has changed over the last 20 years where businesses are up and running 24/7 online. And so, or even the recovery time for these businesses from a disaster or an incident, the expectations are much higher now that things will be back to normal as quickly as possible because there's revenue loss, not just that the customers impacted, but there's money that's no longer being made. So these need to be taken into consideration when the architecture is being pulled together. So two things I want to point out, and this is important because it's part of the disaster recovery. These are good conversation points with the business. One is the recovery point objective. Now this refers to the amount of time that the IT systems can be down for the business, that the business can tolerate. So each business will have different RPO expectations. Those need to be recover point objective and recover RTO, recover time objective. So the first one is RTO, not R. Anyway, when the system is down, what ends up happening is there's an impact to the business. So what you need to end up doing is figure out with the business, how long can you be without this IT system? And that is the time that they will use manual processes, or may say these services will no longer be available until these IT systems are up. The other piece is refers to the data loss tolerance. So how much time can you tolerate without the data? So that's an important piece because without the data, you cannot operate. You need good data to do good work. And so when the systems come up, you want the data to be refreshed and up to date so that all those manual processes that you were doing, that data needs to be entered in, or there's only a certain amount of data outage that you can tolerate as a business. And so that's a good conversation point to have with the business. So those are a couple of things I want to point out for business continuity and disaster recovery for sure. They're important, and it's not acceptable for a system to go down and not come up for for days and days and days. Those operating in that model is no longer acceptable, given the cloud and various other technology capabilities that are available to us. So, moving on, security controls. Security, if you think about it, think of it as a posture. It is not just one thing that security is. It's not just the user passwords. It's not just the administrative accounts. It's not just password management. It's not just the firewall or a network and networking devices that can also provide some security controls or antivirus. It's the whole posture in how you go about securing it. So if you were to use the example of your house, you have a front door, you have a garage, you have a back door, you have a door from the garage into the house. Each room has a door. Each window has an entry point. So if you were to think of security, um, there's so many ways to tackle that, right? You can put glass tampering alerts or sensors on the windows. You can put locks, physical lock and key on all the doors. You can put other additional deadbolt locks on the front door and the back door. Um, and you can put wireless security controls which are motion detection is on. So if someone is moving, then you'll get an alert or it'll alert the authorities or whatever. So if you think about security in the same manner, you have to think about it at the server level. What all is needed to secure the server? The operating system needs to be patched. The servers need to have up-to-date firmware there, so that we can avoid or potentially mitigate any security attacks so that it's protected. The same thing for storage. The storage needs to be encrypted. Data when it's in motion, data when it's in rest needs to be encrypted so that you're securing your storage devices and the data. Then you've got your network devices and switches. Same story there. You want to keep the firmware and the patches updated. Firewalls are your main entry points. How are you going to configure the firewalls? What kind of traffic will be allowed in? Are you whitelisting the data that's coming in or the traffic that you're allowing? And how are you managing it? Are you putting in controls in there for intrusion detection and prevention? And what are some of the other controls you can put policies and rules on the firewalls and on your switches and routers, and how you will reroute traffic if there is a breach or any other issue associated with security. Um, that's just at the hardware level. Then there's the whole logical security posture on how you will place systems in which layers of the network. That whole space is evolving and changing. We're going to software defined network, and in which there's more deep packet inspection, so that zeros and ones that are moving over the fiber optics, you want to know what those zeros and ones are, where they originated, where they're headed, did they get changed? And so there's a lot of that deep packet inspection happening. I think one thing I do want to point out about security is, just because the controls are there doesn't mean you'll put the same level of security on everything. You want to put groups of things together. Like, for instance, your social security number and your name and your date of birth, and those things are more personal about you, and perhaps more important data about the customer, perhaps. Whereas someone interested in listening to music, maybe they like country music, is not the same critical information about someone. So there is something to think about, like data protection, especially for customers. What is the personally identifiable information and what is not considered the same? So just like how you would protect your laptops and your jewelry and maybe your expensive electronics, as opposed to your clothes. if you lose your, maybe if your clothes are not like super expensive, like if they're Prada and Gucci and stuff, then yeah, one could argue. But I'm just saying that if you have a Gap t-shirt and you've got your iPad's worth more, so you're going to care about that and securing that, versus your Gap t-shirt. So anyway, so think about security in those terms, because security costs money, and you have to think about it in such a way that it is, meets the business need. It doesn't get in the way of the business experience, the end user experience, but it's also ingrained so that people can feel confident about using the systems that are designed, and available to them. So um, so that's my spiel on security. I cannot emphasize how important it is, and I'm super excited that there's going to be a whole session just on security. Um, the next thing I want to talk about is IT management, infrastructure management. This is important because you've got all this hardware, you've got all this infrastructure that's getting implemented, just like how you have a car, and the car needs an oil change, and it needs to be, the wheels need to be rotated and needs a wash, and it needs to be maintained. The same thing is true for systems, so that they're optimized and they work at their best maximum capacity, so that we get the full benefit of the infrastructure investments that we've made. We have to track changes because that helps us get out of disasters and incidences quickly. So if we know what happened, then we can get uh, get to that previous state, stable state quickly. So IT configuration management, incident management, change management are some of those processes from ITIL that help with managing the infrastructure. Patching refers to, so Microsoft Patch Day, I don't know if anyone's aware of it or not, or if you've had a laptop from Windows, on Windows, then you will get you'll get patches or nightly updates that Microsoft will say, please install these new patches so that your machine works optimally and you're protected against malware and spam and other security hacks or whatever may be the situation there. So patching refers to the entire layer of the infrastructure: switches, routers, servers, storage. All these hardware pieces have firmware and they have an operating system on it, so they all need to be patched against the vulnerabilities of being attacked. These devices now, if they cannot be down and the expectation is they're up 24/7, 365, you want to monitor them. They need to be monitored so that when there's a process failure, or if the server is reaching capacity, or if there is a anomaly of some sort happening in your network, like some packets are being dropped, you want to know about it before the customer comes and says, I cannot get to your website. You want to know about it before that, so you can avoid it or mitigate it, or whatever is the situation, you can fix it so that there is no disruption in service for the customer, and the end customer has a stellar experience on the website or in the application or whatever the software may be. User account management, again, this is tied to security. Critical piece, figuring out the security. Administrators get separate accounts from their individual login accounts. You do role-based access, so each user is given given an account specific to the type of role that they're going to be playing. So if I'm going to be a user, I don't need administrative privileges for that SharePoint, for that website or that system. So you give people enough to be able to do what they're expected to do for the roles that they play in the organization. Performance management, closely tied with the infrastructure. You want to make sure it's performing optimally. If you're seeing a server fail constantly, or if it reaches 70% utilization and then stops working, those are performance related issues you want to know, because you want to fix them so there's no disruption or degradation in service because of the infrastructure not working properly. IT help desk or service desk, this is pretty common. So every website you go to, there's usually a place where they'll say, hey, if you have issues with this and you want to report something, send us an email. Or there's a bot you can talk to, or there's a live person you can chat with, or you can call us and we'll help you figure out things if you're not happy. So anyway, to be able to do that, you need a service desk who will take these calls and answer the customer questions and help mitigate any issues that they are experiencing on the set website, or it may be with the product itself, or whatever the situation is. So backup and recovery, this ties back with disaster recovery. You want to back up your data and you want to store it in multiple instances or locations in different methods, perhaps. And the reason why you do this is so that if there is a disaster, you can quickly restore your data from the backups you have taken. And this helps to reduce your recovery time. This is going back to that data recovery um, requirements that the business may have for you. End user management. In a company, there's usually business users, and and then you have customers as well. So all these people, especially people within your organization, IT infrastructure is expected to help them with their laptop issues. If you're in school, you probably have an IT department you can go talk to if you've gone use the lab and your printouts didn't come out, or your email's not working properly, or you've reached max storage capacity, or whatever the situation is. You have some place to go and they help you figure out your user access, and they give you a username password, they help you out. So user management pieces are tied with the IT help desk, but end user management aspects of it, they will make sure that your experience there in what you're doing is good. So their primary focus is to make sure that your end user's experience is excellent in using the IT systems or the IT infrastructure that caters to their needs. Incident management refers to disaster recovery. Sometimes things are not every disaster is a big disaster. There may be just an instance where there's an isolated incident because somebody cut the fiber to the data center because they were digging the ditch to put a power line or to put in a telecommunications equipment or something, and they cut through the fiber, so now some systems in the data center are impacted. So that's an incident and that needs to be managed. And that's, and there needs to be a process in how to activate it, who's going to come support it, and make sure that that services are restored to the data center for all the services that got disrupted. Storage management refers to the storage components and how they're managed. You can have multiple things happening with storage. Storage is one of the most expensive infrastructure that is available, that's consumed. So I want you to think about how optimally can the storage be utilized so that it is cost effective for the business. This goes back to asking for requirements related to, of course, disaster recovery, but to backups. How often do you want the data backed up? How many years of data do you need? Do you need 7 years? Do you need 12 years? And why? What format? What data do you need in real time? What data can be um, served to you a little bit slower? What data can we put away because you're going to look at it only once in 2 years? Are there any regulatory requirements associated with the data that we're storing? So these are the questions you want to ask and help put policies in place to move the data from the different storage tiers, so that the cost of the infrastructure is lower. Data center management refers to the building itself. There needs to be certain levels of temperatures that need to be in place. There needs to be dual power. The telecom services like the internet service providers, or um, sometimes they need transport, and those services need to be redundant. They need to be there's usually a battery backup system in place at these data centers as well, just to be sure. Just in case of disasters, you don't just need 2 servers, but if you're really running your own premise data center, or even if you go with a third party, you want to make sure that they have those redundant facilities available to you, so that you can move your servers and systems from one data center to another data center to continue providing the services that the business needs to stay operational. So, so these are some of the the highlighted processes I picked up. I mean, there's a lot. There's problem management, release management, ITIL. If you go through the training, there's a lot of different other process, service management, lots of other components to it as well. I'm showcasing and highlighting at least some of the critical processes that I thought would be good for this for you to know and understand, if you start working in infrastructure, or as you're pulling the solution together for the competition. Cost considerations. So what are some approaches to reduce the costs? Well, the cost is a big conversation. I'm just going to put it out there, because IT systems are not cheap, and companies want to digitalize a lot of things. They want to digitalize the manual processes, get rid of paper, want to use automation, so that there are people, even if it is digital, they're not doing data entry. They want the systems to talk to each other, so that data is transported, is integrated easily, instead of multiple entries, like, oh, I put it in Excel, and then I put it in SAP, and then I put it in this other system on the website. And so instead of manually entering data, even though it's in a computer and it's digital in 3 different places, they want to digitalize that and make sure that data goes from one system to the other, instead of manual interventions, because then once you put manual people in there, it's prone to errors. It's just the way we are. We're humans. um, so when you think about hardware costs and infrastructure costs, and then automation, you want to think about it in these key areas. Compute, I think I've already pointed out, whether you're going to scale up or scale out, and are you going to use cloud, or are you going to go on premise? You have to think of those cost benefit analysis. Um, Cloud versus on-premise, or a hybrid solution. What is the best way to do this? Storage, I've mentioned the different tiers. So tier 1 storage is usually the most expensive storage, which is all flash. VMAX is one of the EMC products that's out there, but that's why those virtual storage networks that are there associated with them. So that's like your top of the line tier 1 storage. Then you have tier 2, which is also equally good, but just doesn't have all the juice that the tier 1 has. And so that's used mostly for, you could use it for warm storage. So data that's requested maybe once a month or twice a month, or at a less frequent schedule. So tier 1 is usually for real time, instantaneous, I need this now, let's serve it, kind of most critical systems. And it's usually the most expensive. You do not want to put your test and QA and dev systems on this tier. You probably want to put it on tier 2. So from tiering perspective and cost perspective, tier 3 is usually storage tier that's used for, or it's called cold. you'll hear the term hot, warm, and cold. So cold storage, and it's not like it's put in the fridge, that's why it's cold. It's cold storage because it's archival storage. It's usually the cheapest storage option, and the data is stored there for historical reasons, for compliance or regulatory, or retention for audits, or the business just wants to keep that data around for analytics for the long term or something. And they're okay with expecting delays in running the queries to extract the data. So that's something to think about. Like, not everything belongs in the top storage tier. Backups are important for disaster recovery. And also sometimes, you've got somebody in the office and they push the button and they deleted a database. Well, that's not a real disaster, but it would be nice to have a backup to restore it so that you can get the system back to its original state quickly. So backups cloud-based backups are becoming very popular, or you can put if you're doing it on-prem, there is and on-premise tape libraries, and then you have to rotate those tapes. Tapes are becoming obsolete. A lot of people are now using some sort of private cloud. So you back them up using different types of technologies, and it's stored in archival, or it's copied around in multiple storage locations so that it can be easily accessed. And it's a lot cheaper way to go than using tapes that need to go get stored, and then when you need to retrieve them, that's a manual call to somebody to bring those over. So some companies are still doing that, but it's becoming less and less prevalent these days. Recovery solutions, these can be different. This is important to think about, like, how are you going to recover your systems in the other data centers? If you have one data center, are you going to put another data center in? Okay, where is it going to be? Are you going to put 3 data centers or 4 data centers, or how are you going to distribute your workload? Meaning, how are you going to recover the application? Is everything going to be in a complete set in another data center? So let's say you have application, web servers, app servers, database servers. Are you going to replicate that entire architecture in the other data center, keep it up in real time? And how are you going to synchronize the data between the 2 data centers? Which system will be primary? Which is the secondary system? Are you going to have what is your configuration going to look like? Are you going to have a primary and a redundant pair at your primary data center, and then also a primary and a redundant at the other data center? Or are they all going to be one primary and then the others are all secondary? So those are some design considerations to think about, and how you're going to fail over your systems and recover your systems in the other data centers. And last, cloud cost management. So on-premise costs are pretty stable. You bought your hardware. Let's say you bought a server rack and you're not going to use, or you bought some storage. You're not going to use everything on day one, but you're going to use it in the next month or 2 in the next year. But you bought all the storage for that year because you had a project. Now in the cloud, in your own data centers, um, whether you use it or you don't use it, that cost is already incurred. So it's already fixed. You bought it, you put it in, it's there. In the cloud, though, it's like a taxi model. And I say the taxi model or the metering model is, just how when you get into a cab and you go from point A to point B, that's all you pay for. Even though the taxi may be going to point C and D and E, you only pay for what you use the service for. So cloud lets you do that. So if there are servers you don't need to use, you can shut them off. If there's storage you're not consuming and you don't need it, you can release it. So you can bring the systems up on a schedule, so they're available from 9 to 5 because that's when you think your customers are going to be there. Or there are project systems that don't need to be up 24/7, so then or non-production environments. So you can save money by doing that. you can turn off these systems and spin them up and consume these services when you really truly need them. And that economics, some people call it cloud economics or cloud cost management. I've heard different terms in the industry, but that's becoming more and more critical because people are starting to look at different cloud providers differently based on these costs. Is it cheaper for me to use Google? Is it cheaper for me to use AWS? Is it cheaper for me to use Azure? And which of these services are the cheapest for my business need and they meet my need, that's the vendor I'm going to use. And now because of this consumption model, in the cloud, you are getting charged for consumption. So just like how you wouldn't bring a taxi, if it's your own car, you can park it in your garage and it's standing there all night long. If it's a taxi, you're not going to put the taxi driver and the taxi or the cab in your garage and let them spend the night there all day waiting for you because you need to go to work at 9 a.m. the next day. So same story here. Your servers, if you need them 24/7, keep them up. If you don't, you want to shut them off because otherwise you're incurring a cost, and the company is going to get charged for it. So and that's becoming a critical issue because costs for cloud are, like I said, they're real, and that if not managed well, can get very disastrous. In some sense, you get a lot of surprise costs at the end of the month, and that's not a good place to be. So this last thing I want to talk about is a support model. So if you look at the diagram, it talks about on-premise. The on-premise model is, like I've said, you own everything. You own the data center facilities, or maybe it's a colo, but still you own the servers, the compute capacity, storage, virtualization, network switches. Everything's owned by you, and you have actual staff that goes and does that. You have a network engineer, you have a network architect, you've got Windows administrators, storage engineers who help configure and set things up. There's someone who's a firewall expert, a security firewall expert, and they're all there helping support the infrastructure, to support the application that runs on it, to provide the service to the business. The other three models that you're seeing there, which says infrastructure as a service, platform as a service, and software as a service, those three belong in the public cloud. So infrastructure as a service, where you see the blue pieces, those are things that the business that you would need to manage. And the gray pieces, the gray boxes, are the ones that are managed by this public cloud provider. So it's a shared responsibility service or support model. And when you put things in the cloud, I want you to be aware of it. And the reason why I say that is because security is a shared model. So they may protect the servers, but you are responsible to, they may protect the physical server hardware. So they have data centers that are secure, and they've got firmware upgrades that they do, and they keep the server patched. But if you put the operating system on that server, you're responsible to make sure that operating system doesn't get hacked, and you're providing the Windows patching on it, and you're doing the monitoring for it, and you're doing the right things so that that server's health is good. So it doesn't eliminate the responsibility, which is where the OS comes in, which is the blue OS box that you're seeing in infrastructure as service. Platform as a service, a few more boxes are now being managed by the third-party provider. So they provide you with a platform where they provide you with the middleware. They're going to take care of the OS. There's some virtualization done also. So they do everything that they were doing for infrastructure as service. And then they're taking care of the OS, the middleware, and the runtime aspects of the application as well. So then your responsibility is to manage the application and manage the data. So data security is still something you want to own, and make sure it's protected when in data at rest and data in motion, and then the database is encrypted. And last but not the least, software as a service. This refers to a model where everything is managed by the third party. So usually this is done by service providers who will manage everything for you. So if you've ever booked on Expedia or Netflix, you're just consuming the service. You don't have to worry about the OS on the server on which your Game of Thrones is stored is patched or not. It's a software as a service. So that's a streaming service which you're consuming. And that's what a software as a service model looks like. Um, Now, hybrid models are interesting, which they don't talk about, but any combination, if I was going to do an on-premise and infra as a service, then that's what my hybrid model would look like. If you've got a SaaS provider application, let's say it's doing bill payments processing from customers for you, that's a SaaS service, but it's talking to your on-prem customer relationship management system, then you've got a hybrid model where you have on-premise CRM and then in the cloud SaaS service. So I want you to understand that even in hybrid models, the support structures are slightly varying depending on the type of architecture that comes into play. So as an architect, you do want to think about what it looks like for the from the support aspect, even though an architect doesn't necessarily do the support and is not the one who's on call for fixing these problems if they do arise. But you want to be cognizant of the fact that this is how it's going to look like, because you're envisioning that that end state of what it looks like and identifying resources and systems necessary to support it once it goes into service. Well, that's all I have. Questions or anything else?
So if you have any questions, please put it on the chat box. So far, no question.
All right, that works for me.
Anyone? Any question for Urmi? Okay, no questions. So
All right.
thank you so much,
Well,
Urmi,
good
for
luck
the
with.
presentation.
Sure, you're welcome, Rakesh, and all the best to all the students who are working on their next deliverable. And maybe I'll see you all, or at least some of you, if I don't know. I know there's people from all over the country participating, so maybe I'll see people on the 16th, I think, is when the mentor, the
Student
next.
mentor get together.
Yep,
Yes,
yep.
absolutely.
So, okay, cool. So maybe I'll see everyone then. If not, maybe at the final day in April when we have the presentation. So all the best, and I look forward to all your solutions. Thank you. Good night.
Thank you. Good night.